Okay, here's an oscilloscope, or a CRO, Cathode Ray Oscilloscope. It is a very advanced form of voltmeter, you might not have realised. What we have is a trace that comes across really rapidly, and you can start to get the feel for it. You know, you can slow it right down, but that is one dot of light, stop it moving, or we can speed up how quickly it goes across. So we can use it to display things that change over time. So this effectively is a time graph running across here, for which we have a time base, which we can set and adjust. And then we have the gain, the vertical gain, or Y gain, because it's the Y axis, which is in volts per division. Now on here, time base per division, each division is a centimetre square that's on there. Okay, so it's quite useful. We can light up that grid, and you can see it a little bit better. I'll turn it off here because it's probably a bit easier. So what I've got going on is I have a wave going in. I'll adjust that wave so I can change its height. Okay, I can see that if I turn it up too much, I'm saturating the amplifier. So I turn it down to a nice smooth sine wave. And what I can do is, if I want to get it more detailed, I can change the height of it, the scale of it. Okay, so I can make it bigger and smaller. I can look at immense details. I can really focus in. So what we've got here, how to use an oscilloscope. You'll need to do this every now and then with a lot of things like waves and electromagnetism. I can move these around, so if I wanted to know the amplitude of this wave, well, I need to know how high it is from the middle position. So if I turn this off a second, that is the middle position. I can set that onto the middle line, and if I turn it on, I know it's symmetrical about that middle lane. But that doesn't help me. I actually want to know the height of it. So what I'll do is I'm always going to measure the biggest distance possible, which is top all the way to bottom, and then divide into 2. So if I want to measure the height of this, it's on a slight slope, so you can adjust this, but it's on a slight slope. I'm going to put that to be the bottom on that line there, and the top, again, I can shift it across so it's on the graduated scale in the middle. I've got 1, 2, 3, 4, 5.2 centimeters, 5.2 volts per division. And my setting here, my scale, is 0.5 for every centimeters. So 5.2, that's going to give me, multiplied by half, is, and I'll leave that up to you. And the answer is, of course, half of 5.2, which is 2.6. So what I'm going to get you to do is I'm going to give you a set of readings. I want you to work out the other way, okay, which is the time base. So from GCSE, you know that the frequency is 1 over the time period. The time period taken to do one complete cycle, top to top, bottom to bottom, going down across the middle to going down across the middle, even though that's not the middle, but that point to that point, or that point to that point. It doesn't matter as long as it's doing the same thing. So for me, I would always, again, if possible, take the readings from up there. Okay, so I'd adjust them, and on this scale then you can count off how many squares there are across. In this case, again, there's the full scale, and that's about 0.4, I'd say, on there. So can you work out for me that frequency? This is frequency 1. The time base is half a millisecond per square. So each one of those squares is half a millisecond. So put that into the calculator, find the frequency for us for that. Then I'm going to go up to frequency 2, so I'm going to squeeze that up a bit, and because it's taking less time, you can figure it must be going to a higher frequency. And again, I'm going to adjust that, just move it down a little bit, and I'm going to adjust that so I'm putting that bottom on the main grid line. Again, have a go at that one. Okay, so it's only doing every 0.2 each of the graduations, but yeah, each centimetre on there is still 0.5 milliseconds across the time axis. Okay, I'm going to click it up a little bit now. Okay, we're going to go up into frequency. That will be far too small, but I'm going to take this one here that I preset. Okay, the time base is wrong for this because the spacing on those is far too small. So I'm going to adjust this and I'm going to turn it so it takes less time to cross each square. And again, that's quite a nice large scale. You'll make it a lot easier to measure if you got them further apart. So what I've got here is 50 microseconds per division. So each square is 50 microseconds, and I'm just going to adjust that. So let's say that nice little strange squiggle on each one. So we're going to go from there, 2, 4, and all the way up to that one. So if you can work out what that frequency is. And then lastly, I'm going to do one more. Okay, now we can write this up and actually use this as evidence in your practicals. So that'll be really useful to do. Okay, so again, much higher. I think we can squeeze it again. So we've gone another one, it's another click, so it's now 20 microseconds per square. So actually, you know, reasonable amount of time there, but again, I will adjust that so we can get, I'll make it easy. Put the left hand one, so a little spike on that line, and then there's our second one there. Okay, so work out the frequencies from those. You've got 4 different frequencies, that's wave number 4 there, and it's going to be fairly high because it's microseconds, so it's going to be a very high frequency pretty much. Okay, and that is how you use an oscilloscope. You can adjust the scale on your graph on the horizontal axis, okay, and space it out that way, or you can adjust the scale on the vertical axis and make it bigger or smaller as need be. Okay, the only other things you need to know is to make sure that works, everything has to be in the calibrated position. You can do some little adjustments with those, but it does change things along. And if you do get that thing, it means your wave is too small and the machine can't stop it. So what you have to do is maybe play with the trigger or adjust it to make it bigger. Okay, and that's basically it. Time base, Y gain, and your position controls.